I'm going to kick off the pre-day today. I'm going to start the first session, the HLC301. This is basically to do with data science and healthcare, running large-scale data processing workloads on AWS. We're going to share this presentation between the three of us. So we'll have Arnaud from Cambia, who's the associate director at Cambia, join us. Rich Ool, who's the CTO and founder of One Strategy, is also going to come in and talk about the implementation details. And I'm Ujjwal Ratan. I'm the solutions architect in AWS with a healthcare and life sciences specialty. I'm also the area of depth SA in the big data group. So basically that means is I work at the intersection of healthcare and life sciences and big data workloads. So the way we are going to do this is divide this entire presentation into three parts. And the first part is going to be covered by Arnaud. He's going to talk about the business problem and what exactly they were looking to solve. Rich is then going to come in and talk about the implementation details. So he's going to show you demos, code snippets, tell you how they went about implementing to solve the business problem that Arnaud laid out. And then in the end, I'm going to come in and tee up the use case with a machine learning demo. So this demo is going to talk about a real-world problem of patient readmissions. And then we'll show how you can solve that by building a very simple application using Amazon machine learning. Just a note before we begin, this is a deep dive session. So we're not going to focus on a lot of the what part of the use case, or what part of the service. We are going to focus rather on the how. So you want to go deep and show you how you can implement similar use cases if you want to. For that, we expect you to have some sort of a familiarity with our services, especially on the big data side, like EMR, S3. If you'd like, you can also see some of our sessions on the architecture track and the big data track. That may make sense for more introductory level service introductions. We also expect a little bit of familiarity with encryption and large-scale data processing on distributed systems, especially Hadoop. That's going to feature heavily in our talk, especially during the Rich's section. So with that, I don't want to take any more time. I'll just hand it over to Arnaud to take us through the first leg of the presentation. Thanks.
Thank you, Ujjwal. Good afternoon, everybody. My name is Arnaud Totti. I'm an Assistant Director of Cloud and Data Architecture at Cambia Health Solutions, and it's a pleasure to be here this afternoon and talk to you a little bit about what we've done with AWS. So Cambia Health Solutions, we are about a 100-year-old company, and our roots lie into the timber industry in the Pacific Northwest, where basically health insurance sort of got its early start when the timber folks started to figure out that if you pool your funds, it would help you with injuries and illness. So from that, about 10 years ago, we as a company started to take on a new course, which is that we wanted to transform healthcare, which is not a small thing to do. We don't like the way things are right now, and we're trying to change that as best as we can. And today we're now a 20-company organization. We're far more than just health insurance, and we've spread into the wellness areas as well. And we are really focusing on embracing the cloud, embracing the more modern technology to bring truly personalized and intuitive healthcare to the individuals out there. So when we started thinking about it, we're like, oh, AWS, good. We want to use that cloud piece to actually get there. How do we go about it? What are the first things we're going to do? And we said, like, okay, let's take that personalization piece. We need to do master data management. We need to figure out in all of our systems where we have records of the same person, but in two different systems maintained in two different ways, or three systems, or four systems. So the master data management one, that's what we want to do. We have one on-prem, but it doesn't perform well, and it doesn't really do as well as we wanted. So that's the one thing that we wanted to focus on. And then data science in general. Just what can we do? Because getting that power and that oomph that data science technology needs to run their models, the cloud is ideally suited for that. So we focused also on the data science analytics. Obviously, that meant that we have to do it securely. You're probably all aware, HIPAA compliance, there's a lot of regulation pieces that you need to take care of. Of course, we really like the pay-as-you-go part, and we really want to fully leverage that piece because that's the part that really comes into play with large models like the data science stuff. And then performance. Our on-prem solution for the master data management was not performing the way we wanted. We really want to get it better at that. So we focused on the HIPAA eligible services, of course, because you're required by the BAA, which a lot of you probably have signed. We wanted it to be scalable, and we also wanted to get some performance on the delivery side. So, hey, if you've got a managed service, we'd like to make use of that. Less work for us, we like that. So we've had our on-prem center, and we went out and AWS, and of course the first thing that ever always comes to mind is security, security, security. So we definitely turned on the CloudTrail and all those things. And if you want to know more about that, on what we do with our CloudTrail logs and such, there's a session tomorrow. It's SEC305 at 12:30, and there's 2 repeats of that as Dev 317, where 2 of our colleagues will actually tell you exactly on how we deal with our logs in a real-time fashion. But what did we do? We went for the data lake. So we built out the data lake to get the data there so that we can process it for our master data management solution. We pretty much followed the model that was presented last year at re:Invent in the BDT 317 session, and you can look it up. It's not that different. And we used their Lambda, Amazon E3, S3, of course, and then for the metadata, Elasticsearch and Dynamo. We used EMR for our master data management, and I'll get into more detail on what we achieved there. And then we used EMR yet again, and Redshift for the actual data science and the analytics. So the one problem that we had was that EMR was HIPAA eligible, but not HIPAA compliant. And this was right after the New York Summit with the announcement that EMR was HIPAA eligible. There was a lot of work still to be done with that. And we'll talk about it a little bit later. Rich will go into detail on what that meant. And of course, we have Elasticsearch that's not HIPAA eligible. Fine for metadata, because there's no HIPAA data there, but we wanted to use it also for HIPAA data. And Rich will talk a little bit about that as well. So back to that master data management piece. So for all of you in the room who know master data management, this should be obvious, but some of you might not have realized yet on what all takes to do master data management. If you look at the left-hand side, pretty much everything is a match except for one attribute, yet there's still 2 different people. If you look on the right-hand side, everything is different except for one attribute, and it's actually the same person. And that sort of like gives you an illustration of the complexity that goes into the logic to figure out how you line up your master data and line it up to be the same person or the same organization, if that's what you're after. So we've got those many, many sources: demographics, geography, lab data, claims, member files, etc. And what we focused on is to build our own homegrown master matching and merging algorithms to start lining that up and to get to the composite record of the best values out there. Because not every record is the best record. You might have to pick and choose between them. So for that, we built it out. We took like a 4-person team, 2 data scientists, 2 ETLers, and Tony might be in the room. I haven't seen him yet. But he was working on that as well. And what we did, we go like, okay, so how do we go about this? How do we make sure that we do it right? Well, the most important thing is the quality of your match. Did you match really the 2 people that should be matched instead of 2 people who should not be matched? So we did a 7,000 record truth set, and we made sure that we checked that by hand and in the real world for the 1,600 plus matches that were in there. Once we had that level truth set to start testing our results with, we started focusing on the quality. And the first one that we did was match correctness. Did we truly match to the right person? And when we looked at the vendor solution, the answer was, well, 98.5% of the time. It's a pretty high score, but for HIPAA compliance, it means that you cannot use it for certain results, because certain purposes, because you still got a lot of gap there. When we went for our first homegrown solution, we had 99.9%. That was a significant improvement. We were really happy with that. Then we did some algorithm tweaking, and we got it to 99.99%. And that's with a 4-person team on EMR. So we were very happy with that. Some of you in the room might have already figured out, to go like, well, hang on, I can hit 100% that easy. That's so simple. I just don't match anything, and I've got a correctness of 100% because I didn't do any wrong matches. Well, okay, so we can't cheat, so what do we need else? Well, we need match completeness. Out of all the matches that are there, how many did you truly find? Okay, that's a different problem. Our vendor found 98.8%. Our first attempt, not so good. Well, that makes sense, because we were far more cautious with our matches. We wanted to up that correctness. So therefore, you take less risk in your matches. Therefore, you are going to get lower in your match completeness. Second iteration, 98.10%. And now, we really liked where we were. This was going like, okay, we significantly increased our correctness, and completeness is on par with the vendor solution. But we had that little snag out there still, which is performance. So let's talk about performance. The one set that we used to test performance with was 17.7 million records with about 1.8 matches. So for our vendor solution on-prem, the average runtime was about 36 hours to plow through that. And that's the average runtime. We had runs well over 50 hours, and we had at least one run that we simply just killed because it just was going on. So what did our first own version run like? 90 minutes on EMR. Now, I'm guessing a lot of you are going like, well, how big a cluster was that? Pretty much the biggest one we could find. But that's the beauty. I've only got 90 minutes of the biggest cluster, and I'm done. And that's the beauty of AWS. And that's exactly what we also told our management. Go like, this is why we moved to the cloud. This is the stuff that we can do. We can process it now in 90 minutes. Then, of course, we tweaked our algorithm. We didn't tweak it just only to get that correctness up and completeness up, but we also tweaked it for performance. And we got it down on the same cluster size to 40 minutes. So that's the kind of achievement that you can get with Amazon EMR when you go out there. And that's the stuff that really has convinced our management that this is where we should go. So what are the next steps that we're looking at? Well, we're looking at using Amazon machine learning itself to actually figure out what kind of cluster size do we need to put in there. Well, we put pretty much the biggest one in there, but that really hit our SLA. But if our SLA has more room, can we do a smaller cluster? Would that be cost efficient? Can we do that? So we wanted to figure out whether machine learning can do that for us. And Ujwal is going to talk a little bit more about what else you can do with machine learning. The other thing, of course, EMR for far more data science models, things that you could think about as well along the lines of do I want to see where there's overpayments or underpayments or underutilization and those kind of things, and how can I help with those kind of things. The other piece that we're looking for, as I hinted towards, we wanted Elasticsearch because we want to search the HIPAA data as well and get our benefit from that. And that's something we have to do on EC2 and Elasticsearch. Well, Elasticsearch is not HIPAA compliant, at least not the managed service, so we have to do something ourselves. Now, these last two things, Rich will talk to you about and give you a good detail on how to secure those. Rich?
Thanks. Thanks, Arnaud. Let's give Arnaud a round of applause. I wanted to add, we'll also have some time for questions. Hopefully at the end, we're going to try and leave some time to do that. We will have a mic, but I just wanted to make sure you guys were clear on that. Arnaud and Cambia has been awesome to work with. My name is Rich Ewell. I am the founder and CTO of a company named OneStrategy. We focus on Amazon Web Services. That's our specialty, and that's exclusively what we do and all we do. We also focus in healthcare, as well as big data. We are here presenting and happy to be participating. We'd love for you guys to stop by our booth, number 408. Come pick up a cloud t-shirt and talk to us a bit. Before we start too deep into the technical details, I want to go through a couple of definition of terms. We're going to be talking about data at various stages. First, we're going to talk about data at rest. And when I'm speaking about data at rest, I want to be clear. We're speaking about data as it's sitting inside of a storage state. We'll talk about data in transit, which specifically is about data as it's being moved from storage into a processing node. And then third, we'll talk about it while it's in process, data that's temporary space. So Cambia came to us with this and said, hey, we want to build this. We need some help doing it. They reached out to us at OneStrategy and said, we need the details of moving beyond HIPAA, from a HIPAA-eligible service to a HIPAA-compliant service. Is that something you can help us with? We worked with them and Amazon Web Services to make sure that the services that we deployed and the automation scripts and configuration that we built for them moved beyond HIPAA eligible into HIPAA compliant. For example, we'll talk a little bit about some of the work we did on Elasticsearch, which is still not listed on the HIPAA eligible services, but they are using it for their healthcare workloads in a compliant manner. The heart of this presentation really comes down to keys and encryption. We use the AWS KMS service, or the key management service. We used it for a variety of different things, and I'm going to talk through the ways in which we used it. But I want to be clear that keys and encryption is the heart of everything that we're doing in this workload as we talk through this. As we look at encryption and REST, there's really two areas that we needed to cover for Elastic MapReduce, or EMR. The first one was the data stored in S3, or their data lake. In order to make sure that we did this, we had to go through and make sure the data that was stored there was encrypted, as well as the configuration files, the bucket policies, all those things made sure that they were actually encrypting the data that was stored inside of that data lake. The second part was the Hadoop file system that runs on the EMR cluster. And we'll talk through the ways in which we enforced or made these things move from eligible to compliance. The first one is EMRFS on S3. We started with an empty bucket, turned on some bucket policies, and there's a sample configuration of what that bucket policy looks like. You can see in here we're essentially denying the ability to put objects unless they're encrypted. So you won't be able to actually write data into this S3 bucket unless the data has encryption turned on. So that's the first gate in which we put out. The second part comes down to that HDFS on the EMR cluster. To do this, we actually use the native Hadoop technologies that are built into EMR. We use the data encryption key and the envelope data encryption key. But instead of using AWS's KMS, we use the Hadoop KMS as it's built into the system. This was done using a bootstrap script as the nodes were provisioned. A couple of the key properties and values you can see here outlined essentially make sure that when we enable that DFS encryption, we've specified some details about it. So we go into the details of the configuration file and made sure that every area in which there was encryption or an option for encryption, we turn that on, making sure that the system stored any of its data on HDFS encrypted. Those are the two parts that we covered and worked on for just encryption at rest. As we move into encryption in transit, we're going to talk specifically about the data as it's moved from S3 into EMR cluster as one of these. So for encryption in transit, the heart comes down to SSL and making sure that the communication channels are encrypted, making sure we're using SSL for all of the communication traffic. To start with this, we use some configuration files in which you can see here a couple of examples where we're enabling the client key store, as well as that trust location and a couple of other parameters. So we dive into a little bit more of the details of this. We're going to look specifically at the encryption in transit inside of the EMR cluster. So not just for data going to and from S3, but inside of the EMR cluster itself. To do that, specifically you have to enable encryption for communications for RPC, or client-type connectivity. This could be things like Hive or Pig, for example. To do this, we used configuration files. For example, in this one, you can see that we're enabling Hadoop RPC protection and setting the level 2 authentication so that any of the communication to and from these to this Hadoop cluster over RPC is encrypted. The next part that we need to take care of is encryption between the nodes. So as an EMR cluster communicates one with each other and the various nodes, we need to make sure that all of the communication traffic is transmitted in an encrypted manner. In order to do that, again, we're just using the data encryption key and envelope data encryption key, as well as the Hadoop KMS. This turned on with the data transfer protocol enables this for all of these nodes to communicate one with another over encrypted channels, making sure that if the data, for example, was being watched, it would be encrypted. It's secure. This is, again, done through a configuration file, which I'm showing a sample of, and some of the sample parameters in here. But you can see you turn on the DFS encrypt data transfer to true. A lot of these things aren't super complex, but they require a knowledge of these systems and how they work, and that's one of the areas in which we specialize at OneStrategy. So let's move on. As an EMR cluster communicates and as it's processing, there's a process called the shuffle and sort. And this is where Hadoop determines which nodes are going to do which processing, which workloads are going to be distributed to which nodes. This communication also has to be encrypted. This MapReduce shuffle is one of these areas in which we needed to make sure was also in the HIPAA, moving from HIPAA eligibility into compliance. We did this through the MapReduce shuffle SSL enabled equals true in some of these configuration files. This is something that's we focused on and is still not available in some of the updates that I'm going to talk about in just a few minutes. But this is an extra value out of going into these details of this service and configuration that OneStrategy focused on with Cambia. Okay, another part that Cambia needed, and this was specific to the way in which they're using EMR, was Spark. Made a big bet on Spark and using Spark throughout their system. Again, this isn't something that's covered through that service that I'm going to talk about in just a minute with AWS, but we worked with them to make sure that the Spark encryption was turned on. For encryption in process, remember we're talking about data as it's processed. Temporary files, log files, those types of things. In order to do this, we use the standard Linux unified key setup for the EMR nodes. We encrypted the volumes on EBS and any of the storage space that's temporary. We use temporary keys. And the reason that we chose temporary keys was for a very specific reason. Temporary space is exactly that, temporary. It should never be used for anything else, and if the data is lost, it shouldn't be a big deal to the business. So in order to make sure that we're meeting that security and compliance requirement, we actually used disposable keys, keys that would never be reused and that we didn't keep around. So that if the EMR node or something is terminated, all of the data in that would be lost for that temporary space, and that was designed or desired. We did this, and this is again a sample of this bootstrap script. So at the time in which these EMR nodes are provisioned, every single node runs this configuration in these bootstrap scripts, which then configures this Linux unified key setup on each of these individual nodes and the space and the storage for them. To summarize, you can see the way in which we work to make HIPAA eligible, become HIPAA compliant for Cambia. You can see how we've covered the data at rest, data in transit, and in process. Again, with all of the communications to and from the EMR cluster. There were some EMR updates that I alluded to earlier. They were released on September 21st of 2016. Now, as you look at these updates, you need to understand that there's not an exact feature parity between what it is that we worked with for Cambia and what actually is inside of these updates. There's a link to that blog article with some details on that, as well as a link to the original article that shows the details about these updates and how they play into the work that we've done. I'm going to summarize it very quickly for you, but there was a security configurations option that was added to EMR. In the security configurations option, there was a couple of things that enabled you to cover some of these elements, and I've highlighted them here for you. You can see for data at rest, you essentially say, I want to require server-side encryption on S3. For local disk encryption, you then specify, I want to use local disk encryption, and here's the key in AWS's KMS that I want to use. For your in-transit, you've also got the area to specify a TLS key, which is used for the encryption in transit or between the nodes, and then in process with that KMS key. Once you've created a security configuration, at the time in which you provision a new EMR cluster, you get an option that says, which security configuration would you like to use? You specify that security configuration, which has those options that are outlined on that previous screen, and then you provision that new EMR cluster. One of the services that Cambia needed and still uses and needs today is Elasticsearch. But as Arnaud mentioned, Elasticsearch is not HIPAA eligible as it's managed by AWS. We worked with them to identify their needs and did the same process for Elasticsearch. We created some provisioning scripts that provision all of the Elasticsearch nodes. They install the Elasticsearch service. They set up the Linux unified key setup for the temporary space. We install and configure a product that is an add-on that was formerly known as Shield, but is now known as Security. That then covered the security encryption between these Elasticsearch nodes, as well as we use the temporary space, which is essentially what all of Elasticsearch is. We use the same process with that Linux unified key setup. As you look at kind of the solution for this one, again, the value add comes into us working with Cambia and other organizations in the healthcare space to make sure that we're meeting this requirement, to move them out of the space of a HIPAA-eligible service to a HIPAA-compliant service. And that's kind of that value add. One of the areas that I didn't mention, but I want to make sure to call out, is that shuffle and sort process to date is not currently included in the HIPAA updates that I talked about from that September 21st. And so that's one of the areas in which you need to make sure that you're aware of as well. A key point that I need to stress, and I want you to, when you leave this, I don't want you to just think, because I focused heavily on encryption, I don't want you to think, oh, if it's encrypted, it's HIPAA compliant. There's actually a lot more that goes into HIPAA compliance and eligibility, and a lot of that comes down to tools. One of the tools that after we had gone through this work, Cambia came to us and said, we need a tool to be able to audit the data sitting in our data lake. We need to be able to see who has access to the data that's stored in our data lake. What permissions do they have for the data that's stored in our data lake? What are the abilities of the users who have this access to this data, and what can they do with it? What are the roles and permissions that are associated? We worked to create some automation and some tool sets for that. We created one that actually shows that the S3 data sitting inside of a bucket is actually encrypted, as well as some of these tools. We're currently working with Cambia. We've open sourced a couple of these tools, which there's a link to a blog and some code that actually has a couple of these tools out there. But I'm going to walk through and give you a demo of that very quickly. In this demo, we've got essentially this first process I'm going to kick off, which is going to show us the compliance information. We're going to go through, and on a bucket, we're going to enumerate all of the IAM users, the groups, and the roles, essentially all of the people that could potentially have access permissions to this S3 data lake. As we go through this, I'm going to get an output or a report in JSON format that shows what users have access to which objects sitting in the data lake and what their permissions are, specifically going into details. This can be run on a regular basis to determine over time what permissions are changing in the environment, right? This isn't something that other services like AWS Config and these other areas cover today. But you can see the output of this going through, showing the paths, the objects, the statements, specifically all of the permissions that are allowed on these objects, moving you out of that space into monitoring and auditing the services. The next part that we're going to show is an encrypted bucket. So we want to look at the objects in this bucket. I'm going to enumerate them, and I want to make sure that they're encrypted. Is the data that I stored in there encrypted in my data lake? As we enumerate these files, we can see that encryption is turned on. We can see the level of encryption and the details about that file. The last part is we're just going to simply enumerate or look inside of one of these files and see that the data is encrypted, that the data is not actually sitting out there in plain text. And if a person without permissions were to come back to it, they wouldn't have access to the data that's stored inside of that data lake. We're going to move on and talk a little bit more about how machine learning plays into this ecosystem that we've worked with Cambia to build. And to do so, we're going to have Ujwal join us on stage and tell us a little bit more about that. Thank you.
Thanks, Rich. Thanks. So you heard Rich speak about how retrospective analysis was built for large-scale data sets on AWS. Now, that is great if you're looking at crunching huge data sets and then processing it at scale. But what if you want to extend this use case to machine learning? That's the next logical step that one should pursue, because they've got this huge repository of data that they got from this exercise. And machine learning model actually expects nice data sets because it makes for accurate predictions. So there are multiple use cases that we can talk about in machine learning today, especially in the healthcare space. You've got predictive analytics that you can use to predict hospital bed utilizations, for example. You can do text classification and mining for prescriptions. You can do medical image analysis. All of these play heavily into machine learning algorithms. But what I'm going to talk about to you today is patient readmission prediction, and basically try and stratify patients based on their risk profile to see whether they are more at risk to come back to the hospital within 30 days, which is what readmissions is. So let's talk about the real world problem first before we go into the implementation side of things. It's part of the hospital readmission prediction program. It's part of the Affordable Care Act. Basically, if a patient goes into the hospital and gets admitted with a condition and is then discharged and comes back to the hospital with the same condition within 30 days, then it's counted as a readmission. And what we are trying to solve here is try and predict which patients are more likely to do so. And machine learning actually plays perfectly in this use case because every patient who comes back with historical data displays a pattern. And whenever we have a pattern to play with, it can be used to predict a target attribute, which I'm going to talk about in the next few slides. So to build a machine learning model in AWS, you have two options right now. You can run those algorithms on your own. You can use an EMR service, as Rich explained, and then use Spark ML, which is, again, Spark is natively supported on EMR. So you can use a class, just check box an option, and then Spark will come pre-installed. You can use that for, based on what Spark ML provides. You have multiple comprehensive options for running those algorithms. The only downside there is obviously, as with any build your own application, you'll have to do more work to train it. There's no support for evaluation. And then, of course, CI/CD, if you want to build a deployment pipeline, which actually deploys model in a continuous pipeline, that becomes a problem. To solve some of this, you can go with a managed service, the Amazon machine learning service that actually provides you 3 algorithms that you can play with. The binary classification predicts between the state of 0 and 1, or yes and no. You can use multi-class classification to predict a category, and then you have regression that predicts a number. It's only 3 algorithms, but as you can imagine, most of your use cases would actually fall into either of these. You're most of the time trying to predict either a number, thinking about, let's say, how much likely is it going to rain tomorrow, right? That's a percentage for which you can use a regression model, just for an example. It's really simple to train, easy to evaluate, and quick to deploy, and it's targeted towards developers. And this is what our focus is going to be today. I'm not going to go into Spark ML and how you can write Spark ML code, but I'm rather going to show you how our managed service, the Amazon machine learning service, helps you build these really quickly, and then it's so easy to deploy. Just to introduce the service a little bit, it's very easy. As I said, it's targeted towards developers. So we don't expect that you have a prerequisite knowledge of data science if you want to use this. It's all API based and can be operated from the console, which is really great. And you can deploy the models to production in seconds. So you don't have to worry about retraining the model, reevaluating it, making sure that everything is right. We take care of that behind the scenes as part of the managed service. So what are we trying to do here? Coming back to the use case. What we are trying to do is basically take a patient, extract all his attributes. So we talk about patient demographics, their history, admission attributes, and any other feature that's relevant to the patient, do some magic. And then what we want to do is put that patient as a high-risk patient, a moderate-risk patient, or a low-risk patient. These attributes, as you would imagine, are totally unrelated. So simple analytics will not work here because simple analytics essentially relies on data sets that's already there, which you can then crunch and build your metrics on. But this is more of predictive analytics, things that have not happened. And that's why this is not magic. There's machine learning that's actually enabling you to do this. And To build this use case, I'm going to use a 5-step process. I'm going to the rest of the presentation, take you through all these 5 steps. First, we are getting the data set into S3. And then I'm using Amazon Redshift, which is our data warehouse, to standardize that data. That's really important because if you put in wrong data sets and give the wrong signals to your model, you really won't get the accurate results. So it's very important that you feed in the right data sets, the complete data sets inside the machine learning model. Then, basically I'm creating a data source with Redshift as my storage. And then I'm building a machine learning model on it. The machine learning service actually allows you to do 2 kinds of predictions. You can either go with a batch prediction. What that does is basically queries the machine learning model with a set of data that you upload, and then generate a prediction batch that goes and uploads into S3. And then what you can do is use that static data sets to build analytics reports, for example, actual versus predicted values. The other thing that's really great is it also allows you to do real-time predictions. What that means is basically you can enable an endpoint, which I'm going to show you, and that endpoint can be queried through APIs for real-time predictions. So what I'm building here is a static website that calls that endpoint through an API call. And then I'm using Cognito to federate the access because I don't want to embed my AWS keys inside my code. So you can use Cognito to make sure you have federated access to that endpoint. The data set that I use for this is from University of Irvine. It's got about 102,000 rows, which is by no means enough to give you an accurate predictive model. What you need to do is train it with much more, which is a very rigorous process. But what you need to take away from this session is this process that I'm outlining is kind of similar with even large data sets. Most of it would be similar. So I'm hoping you're able to look through the process and appreciate that so that you can then use the same process with larger data sets. It covers 10 years of clinical care records with 130 hospitals and has 50+ features or attributes, which I'm going to use to draw connection and correlation to the target attribute. There's a link if you want to play around with it. I highly recommend it. It's a great repository if you want to get started with building machine learning use cases. So the first step that you saw in the diagram was ingesting the data into S3. So what I do is use a simple S3 copy command to get that data on S3. And then as you can see, I listed the bucket and I've got a master and a transaction table. Now, why is this important? I don't want the data to be denormalized from the very beginning. I want to process it. I want to make sure that the keys that I'm using as foreign keys are not just numbers, but have some meaning to it. So what I do is basically create 3 master tables, one for admission source, admission type, and then discharge disposition. And then diabetic data is my transaction table, which is then going to translate into a fact table in the actual data model, in the data warehouse. So let's look at the schema really quickly. So as you see, the fact table is actually about 50 attributes. I would say 51 with the target attribute that I built. And then all the 3 dimension tables are really simple. It just has an ID and a description, not much. But in your case, when you're building with larger data sets, you would want to build a more sophisticated data model for this so that you're 100% sure that the data that you're processing and feeding into your machine learning model is the right one. The next step is actually, once you have the data inside Redshift, you have to load it from S3 and then standardize it. Standardization is really important because it gives the right signals to the machine learning model, as I said. So some of the things you can try with standardization is like updating null values, which is very important. If you don't give complete information to the machine learning model, it won't learn. So it's very important to give it as complete data set as possible to train it. Our service actually splits the data set as 70-30. So you've got 70% of your model that's used to train it, 70%, I beg your pardon, your data that's used to train it, and 30% used to evaluate. So it's really important you give the right training data set. You also have attributes, certain attributes that display a certain pattern. For example, phone numbers, you know that it's going to be in a certain pattern. And if you don't see those patterns in your data set, you might as well go ahead and update it. Geographical data is also a great example. So let's say you have the city information, you can go ahead and update the country, county, continent, etc. Timeline values is also a good example because let's say you know the admission date and the discharge date. Any intervention or observation that happens between those two will happen between those two dates. So if you don't have the dates of your interventions and observations, you can go ahead and update them through a simple script in Redshift. And then the last one is really important because granular values and numbers by themselves do not have a lot of meaning. For example, age, right? If you say, what's your age, and someone tells you 20, that number 20 by itself does not mean anything. But if you tell the machine learning model, okay, I'm young or I'm old, that has much more meaning. So it's a good habit to kind of do away with those granular attributes and group them together as categories that you can then use to train your model. Once you have the data set massaged and ready and standardized, what you have to do is create a data source from Redshift. This can be done in two ways. Either you can either call the create data source from Redshift API, or you can also do it via the console. It works just the same based on your preference. The last thing I want to mention here before I go into the demo is about real-time predictions. As I said, it's really simple to build. What you have to do is just enable that endpoint, which I'm going to show. And then the real-time prediction actually can be used by API calls to send certain attributes to the machine learning model and get results immediately. The way to do this is ml.predict API, which is part of the SDK as well. So you can use that for your API calls. And the response that you get is in the form of JSON. So you can see it tells you what is the predicted value. It gives you the algorithm that was used, and then the predicted model type, which was regression in this case. So now you've seen what exactly is the 5-step process to build this. Now let's try and show this to you in a demo. So I'm going to take you through this entire thing, and by the end you'll have everything ready. So you see the data set that I have on S3. I'm just quickly going to show you the Redshift cluster. I'm using the default parameters for the cluster, but obviously when you're working with much larger data sets, you have to fine-tune your cluster to make sure it's able to process data at that scale. So I do that, I get my cluster up, and then I quickly shift over to show you the visual of the data. I'm using a visualization tool to just make sure that it's easy for you to see this. As you can see, I've got the data set finally dressed up and prepped for feeding into a machine learning model. I've got all the 50 features and attributes here. I'm going to talk about the target attribute. So the target attribute is really important, which is readmission result 1. What this does is basically alternates between yes and no. So this is the attribute that my machine learning model is going to predict in the end. So everything is good. I switch over to the machine learning console, and now I'll try and build that data source that I just created inside Redshift. The way to do this is just go here and say create a data source from Redshift. I specify a few parameters. It lets me create a database name, the username, password, and then I have to create a role. If I don't have a role, I have to create one, but in my case I do. So I create that role and make sure that the access is fine. This space is actually for writing queries. I write a very simple query, which is a select star, but this is ANSI compatible, so you can write any complex joins or anything you would like for your data set to be. The next few steps is just specifying a staging location and then a name for my data source. So I do all of that, and I do a quick verification to make sure everything is fine. And this is happening as we speak. So we are already creating a data source. We have not reached the machine learning model stage yet, but I see my data source is already created, and it has passed all the attributes that were there in my data source. So all 50 attributes are here. Some of the attributes are text, so I want to quickly change that to categorical for the reasons I mentioned before. So I do that really quickly. And then in the end, what I want to do is just focus on the target attribute. This is the attribute that is finally going to be predicted. So I want to make sure that I choose the right data type for this, because the model algorithm would be chosen based on this target attribute. Once I do all of that, it just asks me, is there a target attribute? So I choose that, and I continue. And then I also have to choose whether this data set has an identifier. It's really important, because if you don't choose an identifier, it's going to be taken in the learning process. So I tell the machine learning model, this is an identifier, it's just numbers, don't use it. So I've got my data source created. And now I want to look at what the data source is, what it tells me. So it's really simple. In the first look, you have a lot of visual that's already available, the pre-analysis, some metrics, how many rows, how many columns it contains. I can quickly do a quick visualization to see that how the data set is distributed. I can go to the attribute level and see what the correlation of each of those attributes to the target is. These are the attributes that's actually affecting my machine learning model or the result process. So changing any of these attributes is going to affect the outcome. Once I've done all of that, I'm good to go. I create my machine learning model. I choose all default options for this, but you can go custom and write things called recipes. Recipes are things within AML that allow you to transform your data sets. I did most of my transformation inside Redshift, but you could use the AML recipes as well. So I've got my AML model created. I try a real-time prediction now. So let's try it, right? My model is already created. In the next few minutes, let's make sure that I put the data in. I just put a gender attribute, maybe an age category attribute, and then all I have to do is just click create prediction. So as you can see on the right, you will see the JSON output of what that model gives you. Now I want to try this through the CLI. So my model is set up. My machine learning model is done. It's actually working from the data source that I had. I have to enable real-time predictions, which I just did, and I just copy all the attributes that is needed for that predict API call that I'm going to make through the console. So I just go back to the console, just say AWS machine learning predict, which is the way to call this API, and then just put in the attributes. I go with some records, some options like gender equal to male, race equal to Caucasian, and then just the endpoint value. And then as I put the endpoint value, you will see that the same JSON that you got as an output in the previous screen, you will be able to see this in the CLI as well. So you've made the API call through the console. You've made it through the CLI. Now what we want to do is call this through an API call, because that is the real power. That is the way most of the developers will be using this. They are not going to come back to the console to actually do the prediction. So the way to do this is basically create a website, which I did, host it on S3, because S3 allows you to host the website without any servers. It scales automatically. It's really easy to host. And then make this machine learning API call with all the parameters. So you see the machine learning model ID, the predict endpoint, the records, and then this can be embedded in your code that runs in the browser, and it basically calls that API in real time. So let me switch over and quickly show you what that application looks like. So I tried and build that application myself, and this is the way it looks like. So I hosted this application. It's basically asking me for a few attributes. So let me select a few attributes. So I'll just say gender equal to male, some attributes around admission source. I don't need to select all of them. And what I do is just click the predict button and queries the real-time endpoint and gives me the chance of that patient coming back to the hospital within 30 days. And this has basically been done in the period that I was talking. This application has been built with the set of steps that I just showed you. So it's really simple to use, as you saw. I can change and then play around with this, based on what my condition is. The whole idea is that most of these attributes would be available to you at the time of admission or maybe during the process of a patient's care plan. So you can really keep querying this real-time endpoint and seeing how the results vary. And based on that, you can alter the care plan of the patient if you want to, because the patient is still in the hospital, you still have control. By the time he gets discharged, you may not have that much control whether that patient comes back to the hospital or not. So that's the intention. Now, it's a different case of how easy it is to build a model that accurately predicts this, because you'll need really varied data sets, a large amount of data set to actually build a very accurate model that does this, but the process is going to be the same. So I'm going to quickly switch over and also talk about a blog. So this entire thing that I just showed you is also available as a blog. It has much more details than I just showed you in the presentation deck. It has a link to the GitHub repository that has sample code that is available for you to go and implement or on your own if you want to. And that will allow you to start experimenting with our AML service. So just to end, you saw how the Cambia architecture that Rich implemented talked about retrospective analysis. We just extended that with machine learning. So how exactly this expanded architecture works? Basically, you got all your data sets into S3, which remains common. You use EMR to actually do unstructured data processing. So large amount of unstructured data that cannot be processed by conventional relational database technologies. You can use EMR and Hadoop to actually do that processing, write that data back into S3 and use Redshift to create that structured data warehouse which you use for your machine learning model. If you want to build a website or an application and host it, you can use EC2 instances to run your web servers, or you can, if it's a static website, you can also host it on S3. And if you're going with batch predictions, you can take that entire batch of data, put the batch prediction back onto S3, build custom data marts on RDS, and then use QuickSight, which is our reporting service, BI reporting service that allows you to build reports. So you can build a report something like actual versus predicted value, and then expose it to your end users via the internet. So that's all I had. I just want to end with saying that we have a happy hour today in the Japonais restaurant from 6 to 8, sponsored by Cambia and 8K Miles. You're all welcome to come. Also, about the security session that Arnaud mentioned, I encourage you to check it out. It's happening on November 29th. That's tomorrow from 12:30 to 1:30. Thank you.